Hi and welcome to the 2018 paper 2. This is the junior cert higher level and it's question 10 we're on. So as usual, if you want the set of notes I'm working off, please send me an email at shanetroy@gmail.com and just try these questions yourself before you see the answer, just to see can you get the trick. Now question 10, a lot of words here. It's a 15C for this part. It's just part A. So Grace is putting some stairs into a new house. The diagram on the right shows 3 of the steps in the stairs. Each step consists of a riser and a tread. So the riser is the bit going up on a step and the tread is the bit going across. All of the risers in the stairs are the same size as each other, as are the treads. So it's not uneven stairs, thank God. The table below shows measurements for stairs in private and public buildings. The optimum length is the best length possible. Okay, and you see there minimum for private. Okay, we'll come back at that. Grace's stairs will have the optimum size step for a private building. So we're focused on the private and the optimum and the riser, the optimum there. So that figure and that figure. That's our 2 important pieces of information. Grace's stairs will climb a total vertical height of 2.1 meters. Now be careful here, the tread is given in millimeters, they're talking meters here. There's going to have to be something converted at some stage. It's all metric, so that's good, no converting between feet and whatever. So Grace's stairs will climb a total vertical height of 2.1 meters in total, so she's going to go up that high. Okay, now that's only 3 steps, but imagine all the other steps together. That is the sum of the risers is 2.1. So when we don't know how many steps there's going to be, although I'm sure that's what's asking us, work out the horizontal length of Grace's stairs. That is the sum of the treads. Okay. Now, it can take a bit of time to get it, but we know the height it goes, okay, which is 2.1 meters. We know that each one of these risers, now it's in millimeters, we know the optimum riser is 175. Okay, so that's millimeters. That's the same as 0.175 meters. So basically, how many of them in this? Now that's division. Once we know how many steps there are, we can multiply that by the length of the treads. Okay, which was 250 millimeters or 0.25 meters. Okay, so I have that done on the next page. So for the conversions, okay, of the 175 to meters, I divided by 1,000. Same thing here for the 250 optimum for the tread in a private house. Divide by 1,000, and you got the 0.175 to the 0.25. So once you've done that, you got the conversion, even one of them. Look, you're on the way. Okay, it's your low partial. So I said, when you find out how many steps there are, so I'm dividing the 0.175 into the 2.1, there's 12 steps. Okay, so if each tread is 0.25 meters by 12 of them, that's going to be 3 meters in total, and that's our answer. So when you go through it, it's fairly handy, okay, but it's to get the concept. With this kind of physical thing, if you draw it and visualize it, hopefully you can get to understand what's going on, although there is lots of information. But this is where reading the question multiple times, I would need to read this like many times, embarrassingly high number of times. The times I don't do that, the times I mess up. So you're on your own in an exam, take all the time, focus on what you need to focus on, and try to just get what's going on. If you can't, try get the low partials. Okay, at least you're getting something. So that's part A. Now part B says the angle of elevation of Grace's stairs is marked A. Okay, so you're going to line up from the base of the first step to the base of all the other steps. That creates an angle. Okay, using trigonometry and without measuring. Okay, so don't use a compass. Can't think of the name of it now. Use trigonometry and without measuring, work out the size of the angle A. Give your answer correct at 2.1, sorry, nearest degree, sorry. So the height here we said was 2.1. We worked out that the length across in total for all 12 steps was 3 meters. So if you see it, that's giving us a right angle triangle. Okay. Now in a right angle triangle, we're not told triangle, but by definition, stairs has to be at a right angle. Okay. There's only two sets of formulas that would be of any consequence. That's Pythagoras, okay, which would help us to find the length of the longest side, or the side across in the right angle. Now we're not asked that, okay, we're asked for an angle, so it's going to be one of the trig ratios, sine, cos, tan. So I have them done out here, I have the three formulas written out. Now remember, all sine, cos, and tan are describing the relationships between different sides of a right angle triangle. We call them sine, cos, tan, but you could call it ratio 1, ratio 2, ratio 3, or comparison 1, comparison 2, comparison 3. And sine just relates the opposite side to the hypotenuse. Okay, so this side and this side. Cos relates this side and this side. And then tan relates the opposite to the adjacent. And between those three things, if we know two of the three pieces of information, we can use algebra to solve for the missing piece and then find out what it is. So if you go through the problem solving here, it's the angle I'm looking for. Okay, now I have the opposite and I have the adjacent. So if I try to use sine, okay, I'm looking for the angle. Okay, so that's fair enough. I have the opposite, okay, but I don't have the hypotenuse. I'm missing two of the three things. Sine won't work. If I try cos, okay, I'm looking for the angle. Okay, I have the adjacent, don't have the hypotenuse. Okay, so that won't work. Now tan, okay, I have the opposite, I have the adjacent, I'm looking for the A. So I know two of the three things, and the missing thing is what I'm looking for. So tan is your option. So fill in the formula with the information I have. I want to find out what the angle is, so I find inverse tan of whatever this number is. Now, it happens to be a fraction, okay? So, but it's still a number. The calculator will handle it. I'm getting inverse tan of that to find out what angle corresponds to that particular number, whatever that number is. My calculator retrieved it. As long as I set to degrees, okay, I got 34.9, and that rounds to the nearest degree of 35 degrees. Bog standard trigonometry, once you get what this shape is asking, okay? That's why putting in your own labels, is important to try and just problem solve. What formula you use, again, is just your basic trigonometry problem solving, and then what's this particular shape telling me? And do I realize the information I have? Okay, so that's part B. Now part C here says write down the length of the tread and the riser that would give the maximum angle of elevation for a public building, and then give your answer in millimeters. Okay, so I've taken in the information from before, save you flicking back, okay? But we're looking for this one at a public building and the maximum angle. Okay, so focused on these figures here on the bottom. Now, if you think about it, okay, we're looking for, if that's our stairs, okay, we're looking for the biggest angle possible there. Now, how could we make that angle bigger? The only way is to make this side longer. Now, that's the risers, okay? So if we have the maximum risers all the way along, okay, in a public building, which is 180, that's going to be as big as possible. Therefore, this angle is going to get bigger and bigger. Remember, there's a direct relationship between angle and side. The bigger the angle, the bigger the side, vice versa, the bigger the side, the bigger the angle, okay? So now, apologies, I had to pause that, just I realized I'd put the wrong words in here. Now again, I don't need all this text, that's what put me off. I just need the answer, okay? So the answer should be the maximum riser, which is 180, okay? And you want the smallest side, so if we have that drawn there, you want this to be as small as possible. That's the tread, okay? So the minimum public tread. So this text isn't needed. I just put in there to hopefully make it understandable. And I put the wrong words here, minimum, maximum, the wrong way around. So that's part C, only worth a little bit of marks, but it's fairly hard logic, okay? You have to really know your angles and sides. Okay, that's question 10. Thank you very much.